Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll solve a problem on determining viscosity by rotating cylinder method. So in our last lecture, already we have discussed the theory part and the derivation of rotating cylinder method. So in this lecture, we'll discuss a problem on that. So the problem what I have taken here, the viscosity of a liquid is determined by the rotating cylinder method, and which case, the inner cylinder of diameter is given 20 centimeter is stationary, and outer cylinder of the cylinder is given 20.5 centimeter, contains the liquid up to a height of 30 centimeter. The clearance at the bottom of the two cylinder is 0.5 centimeter. The outer cylinder is rotated at 400 rpm. The torque registered on the torsion meter attached to the inner cylinder is 5.886 Newton meter. Find the viscosity of the fluid. So here the question is given, we need to find out the viscosity here. Okay, so for finding the viscosity by this rotating cylinder method, actually this is the concept of given rotating cylinder method. So before going to solve this, first we need to draw the diagram so that it will be very clear for us to identify the data and understand the concept. So here actually this is the outer cylinder is there, and here one more cylinder is there, like inner cylinder is there, and which is fixed, and this inner cylinder is connected to a torsion part, torsional spring. Actually this is connected to a torsional spring. Okay, and let's give some line like this. So this is the outer cylinder one, and this we can consider this is R2. Here the diameters are given, inner cylinder diameter and outer cylinder diameter given. So that means this is the inner cylinder whose diameter is given 20 centimeter and which is stationary. So this is the inner cylinder part. Okay, and in between this we have the liquid whose viscosity need to be measured. So this is the liquid which is present between these two cylinders. Okay, yeah, now, and this is the inner one, we can give this is R1 and this is R2. So let's write the data given here in this. In case of this inner cylinder, this is the inner cylinder part which is stationary or fixed and which is connected to the torsional spring. So diameter of the stationary one is 20 centimeter. Let's convert this 20 centimeter into meter. So let's write 0.2 meter. Similarly, the outer cylinder of diameter is 20.5 centimeter. This one. This is the outer cylinder whose diameter is given 20.5 centimeter and which contains of liquid 20.5 centimeter, and this one we can write 0.205 meter. And here as I have mentioned here radius, so let's convert this one in terms of radius, because in the future formula we are going to use only radius one. So this one R1 I can write here, this is 0.1 meter, and here it is R2, I can write this 0.1025 meter. Okay, and now contains a liquid up to a height of 30 centimeter. So a liquid which is a height of, it is given, so which is a height of given, this is the height of liquid in the outer cylinder, you can say. So this one we can write height of liquid in the outer cylinder, that is how much given, 30 centimeter we can write, and this is also we can convert into 0.3 meter, and the clearance at the bottom of the two cylinder is 0.5 centimeter. That is this means this is the inner cylinder and this is the outer cylinder, and the clearance between these two cylinder is given. That means this one, and this is small h, and here we can write the clearance between these two small h equal to 0.5 centimeter, and this one again we can write in terms of 0.005 meter. Okay, and yeah, the outer cylinder is rotated, so this cylinder is going to be rotated. Here a shaft will be connected, or rotating, the pulley will be connected so that this outer cylinder will be started rotating, and this is rotating with a speed of, so you can write n equal to 400 rpm, and the torque register on the torsion meter is attached in the inner cylinder. As I told, there is a torsion meter is attached, or torsion spring is attached to this inner cylinder. So here the torque is given 5.886 Newton meter, and we need to find out the viscosity of the fluid. Okay, which viscosity? Now the viscosity of this fluid which is present in between these two cylinders. Okay, so that we need to calculate here. So we know that actually in the previous lecture already we have discussed, for this method we have derived the formula to identify the viscosity. So from that formula we can write, the viscosity mu equal to, we know the formula, 2 into R2 minus R1, R2 minus R1 into H into torsion T, divided by, in the denominator, pi R1 square, omega will be there, and again bracket start. This is 4 capital H small h R2 plus R1 square, bracket start, R2 minus R1, bracket close here. So this is the formula actually, and which we have derived in our last lecture. So now see, in this equation, if you see what are the data are given and what are the data are not given. R2, R1, here it is there, H value it is there, and next is pi value we know, R1 value given, omega is not given, so here n value given, so omega we can write here, we know the formula 2 pi n by 60. So from this formula we can identify the value of omega. Okay, now next is 4h, 4 capital H is given, no, H is not given. H means the H is nothing but, this is the H actually, the height of the inner cylinder which is inside the liquid. See, the height may be more, but the liquid which is present in the, with respect to this inner cylinder, this is H. So this value is not given, but we know the total height of this outer cylinder and we know this clearance, so we can find out the H value from there. Then no problem with that. So H is, small h is given, R2 given, R1 given. So remaining, see, all these values are related based on the R2 and R1, and H and capital N and small h also we can identify. So let's find out first omega, then this H, then we will solve this one. So now I can write omega, as I told, 2 pi n, so 2 into pi into n is nothing but 400, and this is 60. So we can get it here, 2 into pi into 400 divided by 60. So 41.88. This is the omega, 41.88. And the next is H value. As I told, the H equal to is nothing but height of the inner cylinder. And this one we can write here 30 minus small h, the clearance between these two cylinders. So this one we can write 30 minus 0.005. If you see 35 I am writing because it is in the centimeter I am writing, or also you can write this one, or directly you can write centimeter or meter you can write. So anything we can write there. So this is nothing but we can write easily 29.5 centimeter. Again we need to convert into meter also. So that is nothing but 0.295 meter. So all these values we have identified. Now we'll just put this value in the mu equation. So that means 2 into, what is the value was there? R2 minus R1 into HT. So R2 is nothing but how much was there? 0.1025 minus 0.1. 0.1025 minus 0.1, and T value is how much is given? 5.886. Now 5.886 into H value is there. H is nothing but the clearance between these two, 0.005. Now let's write this in the denominator part. What was there? Pi was there, omega is there, that is 441.88, and next R1 square is there here, 0.1, so 0.1 square, and then in bracket started again we have the value of 4H, 4 capital H small h. So 4 into capital H, 0.09295 into small h, 0.005, and into R2 is there. This one R2 is there. So you can write the value of R2, 0.1025. Again you can write plus R1 square. R1 square is nothing but 0.1 square, 0.1 square, bracket start, R2 minus R1. Again same thing will be what was there here, same thing we can write here, 0.1025 minus 0.1, bracket close, then square bracket also we can close it. Now these things we need to solve it in this way, and so what I'll write, again you go for this calculator part. So here you can write 0.1025 minus 0.1, so very small value, into 2 into 5.881 into 0.005 again. So it is very small, 0.00014, 0.0001470, right up to this. Okay, now in the denominator part let's write. So first part we'll write this one, this part we will solve it, then we'll go for the next one. So here we can write pi into 41.88 into 0.1 into 0.1. So this is 1.315, 1.3156, then bracket start. Again if you write, we'll solve this one. So let's write this, 4 into 0.295 into 0.005 into 0.1025, 0.00060, 0.000, again 60, 475 plus, again we'll solve this one. Let's write this one, 0.1 into 0.1 and multiply, again bracket start, 0.1025 minus 0.1 and bracket close. So this is nothing but 4 times 0. So 0 0.4 times 0, 25. So this is here. You can close the bracket. Now see, 4 times 0, 25. Now here we'll do plus 3 times 0, 0 0.123. 3 times 0, 60, 60475 equal to, and then multiply with 1.3156. So get 0.0082. So this is 0.000147 divided by 0.000828. 828. So finally the mu equal to, we are going to get 0.000147 divided by 0.00828. So 0.177, something you will get like this. Okay, so you can write 0.177 or some value you can write here. So this is the value what we got, this much Newton second per meter square. And again we can write we can convert in terms of poise. So poise, if you want to convert, we just need to multiply with that 10 in that. So we'll get the value of 1.77 poise. So thing is that we need to carefully solve this value. So the value may be plus minus some 0.01 or some 0.1 will be maybe there in the calculation, but approximately you should get this kind of value in that. So I hope you understand how to solve the problem. Very simple thing is there. This kind of question may be asked 3 to 4 mark questions, or sometimes 5 mark questions also. Even sometimes in the competitive exams also they may ask which 2 mark questions to solve this. But for solving this one, at least we need to remember this formula. Okay, and here I have given diagrams and I have explained all these things details, but that much time you don't have in the exam, so you can just remember this formula and you just can take this value and put it there. So if you are having any doubt in this, you can give a comment on the comment box. Thank you all.